Okay, today we're going to do convex mirrors. And convex are a little bit different than concave as far as our frame of reference. So what I'm going to do is I'm just going to draw everything with our frame of reference. So again, first I'm going to draw this line. That's going to be my principal axis. And then I'm just going to use this roll of tape, and this is going to be the mirror. Now what's different from yesterday is the reflective part is, remember, is on the outside. So this is the reflective part, the outside, okay? Now yesterday when we drew the circle, it went the other way. So if I was to draw my center of curvature, do you notice that the center of curvature is on the other side of the mirror than when we did the concave? Okay, so this is my center of curvature, which means my focal point is going to be here. Now we're still going to use our same frame of reference, because when I'm putting an object in front of the mirror, the object is still going to be on this side. Okay? So here's the thing when we're doing convex. Today we're just going to do the math, but the difference is here, this is going to be negative, this is going to be positive, just like yesterday. Okay? So what you notice is when we do convex and you're writing your given, F, C, and DI, these are all going to be negative. Does everyone see that? Because they're on this side. Does that make sense? Not on this side. This side is positive. All right? So another thing about convex is when you're doing your problems, when we're working with convex mirrors, and this is in your notes, we know that they're always, the image is always going to be virtual. They're always going to be smaller, and they're always going to be upright. Now, we'll do this in practice when we do ray diagrams tomorrow, and we'll see this when we do it mathematically today, but this is just something to keep in mind, okay? And that's it. So that's our frame of reference. So this is the convex, okay? And that's what we're doing today. So let's look at practice C. And we'll do number 1, I guess, right? It's the first one. All right, so we're going to do C1. So again, one last time, again, our frame of reference is different because yesterday it was different. It was concave and it went this way, and then C and F were on this side. So in your given, F, C, and DI are going to be negative. So that's the key with convex. All right. All right, so now we're going to do C1. So most of the time convex is used for wide angle viewing. The big mirror that I have in this classroom, that's from the media center of the old school. So before they had security system, they used to actually have mirrors around the classroom so kids wouldn't steal books before they got a security system. Okay, so let's look at C1. So it says the image of a crayon. So we're going to write our given. And then we're going to write what we want to find. Okay. So it says the image of a crayon appears to be 23 centimeters behind the surface of a convex. Now when we have the test, you're going to have convex and concave, so obviously you have to read the problem carefully to see which type it is. Okay. So DI is equal to negative 23 centimeters. Okay. It's 1.7 centimeters tall, so the height of the image is 1.7 centimeters. If the mirror's focal length is 46, now remember, this is convex, So we said the focal length is always going to be negative because it's behind. So this is negative 46. This is where this is how people make mistakes. How far in front of the mirror is the crayon positioned? So we want to find DO, the distance of the object. What is the magnification of the image? So we want to find M. And is the image real or virtual? So in order to find if it's, and then it says, is the image inverted or upright? So then we're going to find the height of, and how tall is the actual, they gave us that. So how tall is the actual crayon? It's going to be HO. I was reading a different problem. All right, so where do we start? We want to find DO. So our basic equation is 1 over F is equal to 1 over DI plus 1 over DO. So 1 over the focal length is 1 over the distance of the image plus 1 over the distance of an object. Now yesterday we did all the basic algebra rearranging this equation. So DO is equal to DIF divided by DI minus F. So now I have to be very careful with my signs. Negative 23 times negative 46 divided by negative 23 minus 46. So this is why I say you have to be careful, because a negative times a negative is a positive, and then a negative times a negative is a positive. Okay? So when we put all that in our calculator, we get DO is equal to 46 centimeters. Okay, now we'll look at the next part. They want us to find the magnification. So magnification is negative HI over, so magnification is hi-ho. It's like the songs, you know, the Seven Dwarfs, they go hi-ho, hi-ho, you know that song? So you can go hi-ho, di-do. That'll help you to remember it. All right, now we're not using both of these. I don't have HI and HO, so I'm not doing that part. I have DI and DO, so that's how I know I want to do this part. So it's going to be negative DI, which is negative 23, divided by DO, which I just found out to be 46. So negative and a negative is a positive, and 23 is half of 46, so this is going to be positive 0.5. Now the question asked me if the image real or virtual. How do I know that? So is it real or virtual? Well, I know if it's real or virtual based on DI. So if DI is positive, it's real. If DI is negative, it's virtual. And in this case, DI is negative, so this is a virtual image because DI is negative. Okay. What was the next thing they asked? Is the image upright or inverted? Right? So, is it upright or inverted? And the reason I'm doing this is because we're going to have the same thing on a FRQ on a test. Okay? We're going to draw a ray diagram, and we're going to do a problem where we're going to have to work it out mathematically, and I'm going to ask you all these same questions. Okay? So how do we know if it's upright or inverted? It has to do with M. Okay? If M is positive, it's upright. If M is negative, it's inverted. So in this case, M was positive, so then I know that it's upright. So it's upright because M is positive. And then this was the perfect problem to do, because this problem goes through every single thing that you have to know about convex mirrors. You see what I'm saying? We're doing all the possible questions. And is that it? Oh, we have to find H. What are we solving for? HO, the height of the object. Well, the only equation that had HO was this. So I'm going to use that same equation, but I'm going to use the part that M is equal to HI over HO. And I'm going to solve now for HO. So if you want, you can rearrange the equation. HO is equal to HI over M. And HI was given, and we found M. So HI was given, it was 1.70 centimeters, divided by the magnification. Magnification doesn't have a unit, because when we found the magnification, the units cancel, so it's unitless. And then 1.7 divided by 0.5. Oh, I should be able to do that in my head. Okay, so that's 3.4 centimeters. So that's HO. And that's it. So we pretty much went through every possible thing that we could ask on this one question as far. So this is the mathematical ones. And that's all we're going to do today is convex. And then tomorrow we're going to learn how to do ray diagrams, which means we're going to learn how to do everything that we just did the last 2 days, but we're going to do it graphically. And again, that's our whole problem.